Hello and welcome to another one of D's ADD videos. Today we're going to be looking at the concept of molality. What is molality? Molality is just another way to look at concentration, and it's going to be the ratio of moles of solute over kilograms of solvent. So besides the basic calculations associated with molality, given a solute and a solvent, and information about their masses or densities and so forth. There's also the concept of the fact that when you add a solute to a solvent, there are added intermolecular forces that occur, changes in entropy that occur. And as a result, the boiling point is increased and the freezing point is decreased. Again, placing a solute in a solvent increases the boiling point and decreases the freezing point. Boiling point elevation, freezing point depreciation. What is the main formula for this change of temperature? It's right here. We've got the change in temperature in Celsius equals molality times some constant. Now this constant is going to have one for freezing and a different one for boiling for different solvents. And then a term called the Van't Hoff factor. All right. There's two ways we're going to look at this Van't Hoff factor. One of them is an apparent Van't Hoff factor, and that one's obtained by plugging in your K, your molality, and your change of temperature and solving for I, and usually obtained experimentally. The Van't Hoff factor is obtained by looking at how many ions are formed upon ionization. We can estimate this if we're not looking for the apparent Van't Hoff factor, like I just discussed. To estimate it, what you do is you look at the ionization equation of the solute you're adding, and in this case, for instance, we have sodium chloride. Sodium chloride ionizes into 1 and 1 ions, cation of sodium and an anion of chlorine. So the Van't Hoff factor here would be 2. Beryllium chloride here, what it does is it ionizes into 1 beryllium, but to balance out this little 2 in the box here, we need 2 chlorides. Okay, so we would write a balanced ionization equation, and here there's 1 cation, beryllium, and 2 chlorine ions. So Van't Hoff factor would be 3 here. Organic molecules, hydrocarbons, things containing mainly carbon and hydrogen that will not ionize will have the Van't Hoff factor of 1. All right. You'll see this again in osmotic pressure, so make sure you pay attention to this. So that's basically it. I hope you understand what molality is and its application here for the boiling point elevation and the freezing point and the freezing point depression. If you practice a few of these, look at the example videos, I think you'll be just fine. I hope I've eliminated any doubts you might have over this concept. Check out the example videos. Thank you and have a nice day.